Welcome to the second video in our Class 24 series of lectures videos. Again, we're continuing with the oxidation of alkenes. This particular oxidation is a very useful one that has been practiced by many organic chemists. It's simple. It's called ozonolysis. So everyone here is probably familiar with thunderstorms on the desert, particularly in the monsoon season, except for the last one that we had, where we had relatively few rainstorms and or accompanied by thunder and lightning. But when you have that thunder and lightning, it smells fresh. Believe it or not, that is ozone trying to kill you. It's a very reactive molecule. Obviously, it rips these alkenes to shred. Think about what it does to the organic molecules in your body. But it smells wonderful while it's killing you softly. Here we've got, what, 2,3-dimethyl butene. We subject it to ozonolysis. How do we create ozone? Well, we take a tank of oxygen gas and we pass it through a capacitor across which we, apply a huge amount of voltage, and we create lots of little sparking lightning-like things, and that oxygen is converted into O3. And we bubble that through our solution of alkene, typically at minus 78, because we do not want to blow up. And then in a second step, it's very important to have this second step, because if you concentrate whatever you get after the first step, you could blow up. You got to add dimethyl sulfide or zinc, very slowly and cautiously. Dimethyl sulfide, of course, smells like skunk. So yeah, when we do ozonolysis in lab, our fume hoods aren't great. It smells like a beautiful fresh thunderstorm that's killing us, and then it smells like somebody hit a skunk with their car. What do we get? In this case, we chop that alkene in half and we get a couple of equivalents of acetone. And if we used dimethyl sulfide, we get dimethyl sulfoxide. Or if we use zinc, we get zinc oxide. How about this guy? Here's the trick with ozonolysis. You just split this thing in two, right? And you insert two oxygen atoms, one with a double bond to carbon 5 and one with a double bond to carbon 1. So here we have our aldehyde from carbon 1, and there we've got our ketone from carbon 5. Plus DMSO. In your exams, who knows, I might not be, so energetic as to write the whole thing out. Oops, I lost the O in my DMSO. There, I got it back. I might just, take whatever I've drawn and insert those two oxygens. Don't just insert one oxygen. That is not correct. There need to be two oxygens, right? Where did the third oxygen go? It went with the dimethyl sulfide to become dimethyl sulfoxide. I'll show you a mechanism. You don't really need to know the mechanism. But hey, it's nice to know a mechanism, right? Because it's like the behind the scenes. What's happening? What is the mechanism? Here we go. It's a 3+2 addition, right? 3 atoms from our ozone, adding to the 2 atoms of our alkene. Doesn't matter if you use this Lewis structure and double-headed arrows. You could use this Lewis structure, and you could use single-headed arrows, like a diradical reaction. Doesn't matter to me. You get something called a malozonide, bad ozonide. And what happens to this? Well, it's unstable. It sort of breaks apart into these creatures, and then they rearrange, and you get something called an ozonide, and this is where it stops. And so if you concentrate this is an organic peroxide. This is explosive, shock sensitive, right? It will blow you up. Not fun. So, how do you know your ozonolysis is done? Believe it or not, ozone is a very intelligent form of the color blue in solution. So as long as it's chewing up alkene, ozone does not build up in your solution. But once you've chewed up all the alkene, you saturate your solution and it appears blue, and then you know you're done. And then, very carefully, you drip in dimethyl sulfide, or zinc powder, I guess. Dimethyl sulfide's easy to use, easy to transfer, right? Liquid, stench. But it saves you, right? And this is the reaction, right? You take one of these oxygens away, and it becomes dimethyl sulfoxide, and then you get your carbonyl compounds out. Very nice mechanism. That's it. Another short and sweet video. Only a few more to go. See you next time.